Okay, so the derivative is a quotient rule. Low, d high, I put the negative on the top, so my derivative of the top would be a negative 2x, minus high, positive now, x squared, d low is a 3. Draw the line and square below. Okay, good so far? Distribute and combine like terms. So I get a negative 6x squared plus 12x plus 3x squared. Bottom stays the same. Combine like terms. What do we get? Negative 3x squared plus 12x. Okay, now for this problem, they want you to find intervals of increasing and decreasing. So we're doing a first derivative sign chart, right? So set the numerator equal to 0 and the denominator equal to 0. When I set the numerator equal to 0, I'm going to factor, okay? Factor out a negative for sure, and I can factor out a 3, and I can factor out an x. So I'm going to factor out a negative 3x, and I'm left with x minus 4. And in the denominator, I don't know. So this is my current factor derivative. Okay? Set each factor equal to 0. In the numerator, I get x equals 0 and x equals 4. In the denominator, if I set that equal to 0, I'll get x equals 2. I'm going to do a first derivative sign chart. 0, 2, and 4. Okay, we're looking at the factored form of the derivative, which is this. Since the denominator is squared, it's always positive. I don't even have to think about it. So I really only need to plug into this numerator. Okay, left of 0, I'd have negative 1. So this would be a positive times a negative, which is a negative. Between 0 and 2, I'll plug in a 1. Negative, negative. Between 2 and 4, I'll plug in a 3 and get a negative. Did I do that right? Plugging in a 3. Get a negative 9. Negative, that's positive. Okay, double check my math since I've screwed up the last one. The issue for this one, and the reason I wanted to make sure I went over it, is critical points. Critical points are where the derivative is 0 and undefined. 0 or undefined. So I just kind of automatically say that all of these are critical points, right? But they don't list all of them. Why do they not list the 2? And I probably, even on the AP exam, this would get me, because I'd be in a hurry and I'd miss it. It's not even a calculus issue. 2 is not even a point on the graph. Oh. Look at the original function. On the original function, can x be 2? Why? What's happening at 2? There's a vertical asymptote there. So can it be a critical point if there's no point on the graph there? No. So it doesn't affect your answer for increasing and decreasing, okay? But it does if they ask, technically, if they ask what is the critical point, you can't include a point that's not even a point on the graph. So that's why I chose to go over this one, okay?